Hello guys, my name is Nikander. I'm a professional blockchain developer. Would you like to create a Telegram mini app like Notcoin, Hamster Combat or TapSwap? In this guide, I'm going to show you how to implement JWT Authentication and protected routes in a Telegram mini app using Next.js 14. You can't create such a Telegram mini app without proper authentication. Using JWT authentication and protected routes is one of the best practices to ensure security and functionality. Before we begin, I would like you to check out my full Telegram mini app clicker game code. It's a full stack Next.js 14 app with a beautiful frontend and a robust, efficient backend. It has all the features a good Telegram clicker game should have, with flawless synchronization of the frontend with the backend and database. You can buy it on my official website nikander.com right now. All buyers can download all upcoming updates with new improvements and features for free. Just connect the wallet with which you originally bought the code. I publish news and updates related to the project in a Telegram channel. All links are in the description. Let's continue with the topic of this video. Open VS Code, create a new Next.js 14 project, npx create next app latest. Dot means we want to work in the current directory. Would you like to use TypeScript? Yes. ESLint? Yes. Tailwind CSS? Yes. src? No. UpRouter? Yes. Customize import? No. Wait for a few moments while the project is being created. We need to install two libraries, TWA-Dev SDK for interacting with the Telegram Web App SDK and Jose for handling JSON Web Tokens for authentication. In the root directory, create a folder named utils and inside utils create a file named session.ts. Define a constant key using the text encoder to encode the JWT secret environment variable. This key will be used for signing and verifying JWT tokens. Define a constant session duration set to 1 hour in milliseconds. This duration will be used to set the expiration time for JWT tokens. Create an asynchronous function named encrypt that takes a payload as an argument. This function uses the signJWT class from the Jose library to create a new JWT token with the following properties. Sets the protected header with the algorithm HS256, sets the issued at time to the current time, sets the expiration time to 1 hour, signs the token using the predefined key. The function returns the signed JWT token. Create an asynchronous function named decrypt that takes a JWT token as an input string. This function performs the following steps. Uses the JWT verify function from the Jose library to verify the input token. It verifies the token using the predefined key and the algorithm HS256. Extracts the payload from the verified token. Returns the payload. This function effectively decodes and validates a JWT token, returning its payload if the token is valid. Create an asynchronous function named getSession, which retrieves the session cookie using the cookies function from Next.js headers. Logs the session value for debugging purposes. Checks if the session cookie exists. If it doesn't, the function returns null. If the session cookie exists, The function decrypts the session using the decrypt function defined earlier. Returns the decrypted session data. This function retrieves and decrypts the session data stored in a cookie, allowing access to the session information if it exists. Create an asynchronous function named updateSession. It retrieves the session cookie from the incoming requests. If the session cookie doesn't exist, the function returns immediately. If the session cookie exists, the function decrypts the session using the decrypt function, refreshes the session expiration time by updating the expires property with the current time plus the session duration, creates a new response object using nextResponse.next, sets the update session cookie in the response with the new expiration time, encrypts the updated session data using the encrypt function and sets it in the response cookie, returns the response object. This function ensures that the session is refreshed so it doesn't expire, updating the session expiration time and saving it back in the cookies. Inside the utils folder, create a new file, telegramauth.ts. Define 3 TypeScript interfaces. User represents the structure of a user object, has optional properties, ID, username, and any other additional properties as key value pairs. Validated data represents the structure of validated data, contains key value pairs where both the key and value are strings. Validation result represents the result of the Telegram web app data validation, contains 3 properties: validated data, an object of type validated data, or null if validation fails. User, an object of type user containing user information. Message, a string containing a message about the validation result. Define a function, validate Telegram web app data, that takes a string parameter Telegram init data and returns an object of type validation result. This function is responsible for validating the data received from the Telegram web app. Retrieve the bot token from the environment variables and store it in a constant called bot token. This token is used to validate the Telegram web app data. Initialize 3 variables. Validated data to store the validated data initially set to null. User to store user information initially set to an empty object, and message to store any validation messages initially set to an empty string. Check if the bot token environment variable is set. If it's not set, we return an object with the message bot token is not set, validated data set to null, and an empty user object. Create a URL search params object from the Telegram init data string and retrieve the hash parameter from it. If the hash parameter is missing, we return a validation result indicating that the hash is missing from init data and set validated data to null and user to an empty object. Delete the hash from the init data. This is done because the hash itself is not part of the data to be validated. It's used to verify the integrity of the remaining parameters. Retrieve the useDate parameter from the init data. This parameter indicates the time when the authentication data was generated. Check if the useDate parameter exists in the init data. If it's missing, we return an error message indicating that the useDate is missing from the initialization data, along with null for validated data and an empty user object. Parse the auth date into an integer timestamp and get the current timestamp in seconds. Then calculate the time difference between the current time and the auth date. We also define a constant for 5 minutes in seconds. If the time difference between the current timestamp and the auth date is greater than 5 minutes, we return an error message indicating that the Telegram data is older than 5 minutes with validated data set to null and an empty user object. Create a data check string by converting the URL search params entries into an array, sorting them by key, mapping each key value pair to a string in the format key equals value, and joining these strings with new line characters. This sorted data check string is used for verifying the integrity of the Telegram data. Generate a secret key by creating a hash-based message authentication code using the SHA-256 algorithm with the string web app data and the bot token. Then we calculate a hash by creating another HMAC using the previously generated secret key and the data check string, resulting in a hexadecimal digest. This calculated hash is used to validate the integrity of the Telegram data. Check if the calculated hash matches the hash from the Telegram data. If they match, we proceed with the validation. Convert the init data to an object called validated data and set the success message. Attempt to parse the user data from the validated data object. If the user data is successfully parsed, it's stored in the user object. If parsing fails, we log an error message and set validated data to null. Finally, if the hash validation fails, we set the message to indicate the hash validation failure. Return an object that contains the validated data, the user information, and a message indicating the result of the validation process. Create a new folder inside the app folder called API. Inside the API folder, create another folder named auth. Then, inside the auth folder, create a file named route.ts. Define an asynchronous function post that handles post requests to our API endpoint. Extract the init data from the JSON body of the incoming request. Validate the init data using our validate Telegram web app data function. Check if the validated data exists in the validation result. If it does, we proceed. Otherwise, we return a JSON response with the validation message and a 401 status code. Log the validation result to the console and create a user object containing the user's Telegram ID from the validation result. Create a new session by setting an expiration time for the session using the current date and session duration. Then we encrypt the session data, which includes the user information and expiration time. Save the session in a cookie named session. The cookie is set with an expiration time and marked as HTTP only for security, which means it cannot be accessed via JavaScript. Return a JSON response indicating that the authentication was successful. Create a new folder inside the API folder called session and then create a route.ts file inside the session folder. Create a GET endpoint for the API/session route. Define the GET function. This function will be executed when a GET request is made to API/session. Call getSession to check if there is a valid session. If a session is found, return a JSON response with isAuthenticated true. If no session is found, return a JSON response with isAuthenticated false and a 401 status code indicating unauthorized access. Create a new folder called Components, and inside this folder create a file named telegramauth.tsx. Define the Telegram auth component and export it as the default export of the Telegram auth.tsx file. Specify that this file is a client-side component. Define a state variable isAuthenticated with initial state set to false. Initialize the router constant by calling useRouter. This hook from Next.js gives us access to the router object, allowing us to navigate programmatically within the application. Define an useEffect hook to run the checkAuth function once when the component mounts. The checkAuth function sends a GET request to the API/session endpoint to check if the user is authenticated. If the response is successful, we set the isAuthenticated state to true. Define an AuthenticateUser function to handle the authentication process for the user. Import the web app from the TWA dev SDK package and initialize it using webapp.ready. Then retrieve the init data from the web app. Check if init data is available. If it is, we send a POST request to the API/auth endpoint with the init data as the payload. If the response is successful, we set the user as authenticated and refresh the router. If the response is not successful, we log an error and set the user as not authenticated. If there is an error during the request, we catch it, log the error, and set the user as not authenticated. Define a div element. Inside this div, we conditionally render content based on the isAuthenticated state. If isAuthenticated is true, we display a p element with the text authenticated and a button that, when clicked, navigates to the protected page. If isAuthenticated is false, we display a div containing a p element with the text "You need to be an owner of this account" and a button that, when clicked, triggers the authenticate user function. Go to page.tsx inside the app folder. Clear all the code. Make the home function asynchronous. Use getSession to fetch the current session data. Show the session data in a formatted JSON string. Include the Telegram auth component for handling user authentication. Create a new folder inside the app folder called Protected. Then create a page.tsx file inside this folder. Make a simple page component. The final step is creating a middleware.ts file in the root folder. This file is usually used for handling various tasks that need to be executed before reaching the actual route handlers, such as authentication, login, and request validation. In our case, we'll use it to manage authentication and session updates for our protected routes. The middleware first checks if the request URL starts with protected. It tries to retrieve the session using the getSession function. The session data is logged to the console for debugging purposes. If no session is found, it redirects the user to the home page. If a session is found, it updates the session to refresh its expiration time using the updateSession function. The config object specifies a matcher property that lists the URL patterns that middleware should handle. This configuration ensures that the middleware runs for all requests to protected routes and API endpoints. Let's build the project to see if we have any errors. npm run build. Great, we have no errors. Now we can upload it to GitHub and deploy to Vercel. Don't forget to provide environment variables on Vercel. Bot token is the secret token of your Telegram bot, where you want to use this app. JWT secret is a randomly generated long string that is used to sign and verify JWT tokens for secure authentication. Let's open this app in Telegram and see how it works. As you can see, my current session is null. I need to click on the Authenticate button to authenticate myself. Now I can see all the validated data. This means I'm the owner of this Telegram account and I can access the protected page. It works awesome. You can't create a secure Telegram mini app without this knowledge. That's it for today, folks. Thank you for watching. If you found this video helpful, please like and subscribe. See you in the next video.